You'll thank yourself later for watching this before your interview. What is early stopping and how does it prevent overfitting in machine learning models? Answer: early stopping is a technique used to prevent overfitting in machine learning models. During training, the model's performance on a validation set is monitored. When the model's performance on the validation set stops improving, training is stopped, ensuring the model doesn't become overly complex and overfit the training data. This prevents the model from memorizing the training data and generalizing poorly to new, unseen data. By stopping training when the model's performance plateaus, early stopping helps to find a good balance between model complexity and generalization ability, reducing the risk of overfitting. What are the main differences between k-means and KNN algorithms, and how do they differ in their approaches to clustering and classification? Answer: k-means is an unsupervised clustering algorithm that groups data points into k-clusters based on their similarity. It does not require a target variable or labels for classification. On the other hand, KNN is a supervised classification algorithm that predicts a data point's class based on the classes of its k-nearest neighbors. The main difference is that k-means is used for clustering and KNN is used for classification. K-means is an unsupervised algorithm, whereas KNN is a supervised algorithm. K-means does not require a target variable, whereas KNN requires a target variable for classification. In summary, k-means is used for clustering and KNN is used for classification, and they differ in their approaches and requirements.
What is a support vector machine SVM? Answer: a support vector machine SVM is a type of classification algorithm that helps to separate data points into different categories by finding the optimal hyperplane, which is the line or plane that maximizes the distance between the data points of different classes. This means that SVM tries to find the best boundary between different groups of data, making it a powerful tool for classification tasks. What is kernel SVM and how does it work? Answer: kernel SVM is a type of support vector machine SVM that uses kernel functions to transform data into a higher dimensional space. This allows it to separate non-linearly separable data by finding an optimal hyperplane in that space. In traditional SVM, data is separated by a hyperplane in the original input space. However, if the data is non-linearly separable, traditional SVM cannot separate it. Kernel SVM solves this problem by mapping the data into a higher dimensional space where it becomes linearly separable. The kernel function is used to transform the data into this higher dimensional space, and then the SVM algorithm is applied to find the optimal hyperplane. This allows kernel SVM to separate non-linearly separable data and make accurate predictions. How does the random forest algorithm work? Answer: the random forest algorithm works by building multiple decision trees and combining their results to improve accuracy. Each decision tree is trained on a random subset of the data and features, which reduces overfitting and increases the model's robustness. The final prediction is made by aggregating the results from all the decision trees, allowing the algorithm to learn from the strengths of each individual tree and make more accurate predictions. This ensemble approach helps to reduce the risk of overfitting and improves the overall performance of the model. Knowing the theory is one thing. Answering like a pro in an interview is another. Test yourself the smart way at MLQscafé.com, where real questions, instant feedback, and daily progress tracking help you stay sharp and interview ready. Now let's get back to the next question. What is the main difference between decision trees and random forests in machine learning? Answer: the main difference between decision trees and random forests is that decision trees are single trees that make predictions based on a set of rules derived from their features, while random forests are collections of multiple decision trees that vote on the final prediction. This voting process in random forests leads to better accuracy and reduced overfitting, making it a more robust and reliable method compared to a single decision tree. What is ensemble learning and how does it improve the accuracy and robustness of machine learning models? Answer: ensemble learning is a technique that combines the predictions of multiple machine learning models to improve their accuracy and robustness. This is done by training multiple models on the same dataset and then combining their predictions to make a final prediction. This approach can improve the accuracy and robustness of the models by reducing overfitting, increasing diversity, and reducing the impact of individual model errors. For example, if one model is biased towards a particular class, the ensemble can correct for this bias by combining the predictions of multiple models. This technique is commonly used in applications such as image classification, natural language processing, and recombinator systems. What is boosting in machine learning, and how does it work? Answer boosting is an ensemble technique in machine learning that combines multiple weak learners, such as shallow decision trees, to create a strong model. This process works by having each learner try to correct the mistakes of the previous one, gradually improving the overall accuracy of the model. Each learner is trained on the same data, but with a different set of weights, which helps to identify and correct the errors made by the previous learner. This iterative process continues until the desired level of accuracy is reached, resulting in a highly accurate and robust model. What is bagging in machine learning, and how does it work? Answer bagging, also known as bootstrap aggregating, is an ensemble technique used in machine learning. It works by training multiple models on different subsets of the training data. Each model is trained on a random selection of the training data, which is called bootstrapping. The predictions made by each model are then combined to make the final prediction. For regression problems, the predictions are averaged, while for classification problems, the models vote to determine the final class. This technique helps to reduce the variance of the model and improve its performance by combining the strengths of multiple models. What is a neural network? Answer: a neural network is a type of computer system that is designed to work like the human brain. It is made up of many small parts called nodes or neurons, which are connected to each other in a special way. These nodes are organized into layers, and they work together to help the network learn and make decisions. Neural networks are often used for tasks like recognizing images, understanding speech, and translating languages. They are very good at finding patterns in data and making predictions based on that data. This makes them very useful for many different applications like self-driving cars, medical diagnosis, and more. What is data augmentation, and why is it important in deep learning? Answer: data augmentation is a technique used in deep learning where existing training data is modified to create new examples. This is done to increase the diversity of the training data, which helps the model generalize better and reduces overfitting. By creating new examples, the model is trained on a broader range of data, making it more robust and accurate in its predictions. This is especially important in deep learning, where models can easily overfit to the training data, making them less effective on new, unseen data. Data augmentation helps to mitigate this problem by providing the model with more data to learn from, making it a crucial step in the training process. What is SMOTE, and how does it help in addressing imbalanced datasets? Answer: SMOTE is a technique used to handle imbalanced datasets by generating synthetic examples for the minority class. This is done by interpolating between existing minority class samples, creating new samples that are similar to the existing ones. By increasing the number of minority class samples, SMOTE helps to balance the dataset, allowing the model to learn from the minority class examples more effectively. This, in turn, can improve the model's performance on the minority class and overall accuracy. SMOTE is particularly useful when dealing with datasets where one class has a significantly larger number of samples than the other, as it can help to reduce the impact of class imbalance on the model's performance. What is dimensionality reduction using TSNE, and what is its purpose? Answer: dimensionality reduction using TSNE is a technique that reduces high-dimensional data into 2 or 3 dimensions for visualization. Its purpose is to preserve the local structure of the data, making it useful for exploring patterns in complex datasets. This allows us to better understand and visualize the relationships between data points in a low-dimensional space, which can be difficult or impossible to do in the original high-dimensional space. By reducing the dimensionality, TSNE helps to identify clusters, patterns, and relationships that might be hidden in the high-dimensional data. What is the central limit theorem, and how is it used in machine learning? Answer: the central limit theorem (CLT) is a statistical concept that states that the distribution of sample means approximates a normal distribution as the sample size increases, regardless of the population's distribution. In machine learning, the CLT is applied in statistical analysis and hypothesis testing. For instance, when analyzing the performance of a machine learning model, the CLT is used to assume that the sample means of the model's predictions follow a normal distribution, allowing for the application of statistical tests and confidence intervals. This enables machine learning practitioners to make more accurate predictions and draw meaningful conclusions about the model's performance. How do you handle multicollinearity in a dataset, and what are the methods used to address it? Answer: multicollinearity occurs when features in a dataset are highly correlated, which can lead to unstable and inaccurate model results. To handle multicollinearity, two common methods are used: removing correlated features and applying dimensionality reduction techniques like principal component analysis (PC8) to create uncorrelated components. Removing correlated features involves identifying and eliminating the features that are highly correlated with each other, which can help to reduce the impact of multicollinearity on the model. On the other hand, dimensionality reduction techniques like PCA transform the correlated features into new uncorrelated components that can be used in the model. By using these methods, you can address multicollinearity and improve the accuracy and stability of your model. What is feature selection using mutual information? Answer: feature selection using mutual information is a technique where features with high mutual information with the target variable are selected for a model. This means the features that are highly dependent on the target variable are chosen, ensuring they provide valuable information for predictions. In other words, it helps to identify the most relevant features that are strongly related to the outcome and ignores the ones that are not. This approach is useful when dealing with high-dimensional data, as it can reduce the number of features and improve the model's performance. What is the difference between mean squared error MSE and root mean squared error RMSE, and how do they relate to each other? Answer: the mean squared error MSE measures the average squared difference between predicted and actual values, emphasizing larger errors due to squaring. The root mean squared error RMSE is the square root of MSE, which provides a measure in the same units as the predicted variable, making it easier to interpret. In other words, RMSE is a more intuitive and interpretable version of MSE, as it gives a direct measure of the magnitude of errors, rather than the square values. What is mean absolute error MAE and how is it used to measure model accuracy? Answer: mean absolute error MAE is a way to measure how accurate a model is by calculating the average absolute difference between the values it predicts and the actual values. This means it adds up the differences between the predicted and actual values and then divides by the number of values. This makes it less sensitive to outliers compared to mean squared error MSE, which squares the differences. MAE is used to measure model accuracy because it provides a straightforward way to understand how well the model is performing without being affected by extreme values. It's a simple and effective way to evaluate the performance of a model and make improvements. What is the phone score and how is it calculated? Answer: the phone score is a measure of the accuracy of a model in imbalanced datasets. It's calculated by taking the harmonic mean of precision and recall. Precision is the ratio of true positives to the sum of true positives and false positives, while recall is the ratio of true positives to the sum of true positives and false negatives. The phone score was calculated as phone equals 2 times precision times recall / precision plus recall. This formula provides a balanced measure of both precision and recall, which is important when dealing with imbalanced datasets where one class has a much larger number of instances than the other. The phone score is a widely used metric in machine learning and natural language processing to evaluate the performance of models. How do you choose the right evaluation metric for your model? Answer: when choosing the right evaluation metric for your model, you need to consider the type of problem you're trying to solve. For classification problems, you can use metrics like accuracy, precision, recall, phone score, and ROCOC. For regression problems, you can use metrics like MSE, RMSE, ME, and R-squared. If you're dealing with imbalanced data, it's better to use metrics like phone score or precision recall curve instead of accuracy. By considering the problem type and the characteristics of your data, you can choose the most suitable evaluation metric for your model. What is the Matthews correlation coefficient in CC, and how is it used to evaluate binary classification models? Answer: the Matthews correlation coefficient in CC is a metric used to evaluate the performance of binary classification models. It takes into account all 4 possible outcomes of a classification: true positives, true negatives, false positives, and false negatives. The MCC value ranges from -1 to 1, with a value of 1 indicating perfect classification, 0 indicating random classification, and -1 indicating perfect reversal of classification. The MCC is a balanced metric, meaning it is not biased towards any particular class, making it a useful tool for evaluating the performance of binary classification models. It provides a comprehensive measure of the model's accuracy, allowing for a more accurate assessment of its performance. What do the values +1, 0, and -1 represent in the context of prediction? Answer: the values +1, 0, and -1 represent the level of accuracy in prediction. A value of +1 indicates perfect prediction, where the prediction is correct every time. A value of 0 indicates random prediction, where the prediction is no better than chance. A value of -1 indicates total disagreement, where the prediction is always incorrect. These values help to measure the quality of a prediction model. How does a recommendation engine suggest products or content based on user behavior and preferences? Answer: a recommendation engine suggests products or content by using techniques such as collaborative filtering and content-based filtering. Collaborative filtering finds similarities between users or items based on past behavior, while content-based filtering recommends items similar to those a user has liked in the past. The engine analyzes user data such as browsing history and purchase records to identify patterns and make predictions about what a user might like. This information is then used to generate personalized recommendations, increasing the likelihood of users discovering new products or content that align with their interests. By combining these techniques, a recommendation engine can provide users with a tailored experience, enhancing their overall satisfaction and engagement. How do you design an email spam filter using machine learning? Answer: to design an email spam filter using machine learning, you start by collecting a large dataset of labeled emails, where each email is classified as either spam or not spam. Then, you extract features from the emails, such as the frequency of certain words, the presence of specific keywords, and metadata like the sender's email address. Next, you train a classification model, such as naive Bayes or support vector machine SVM, using the labeled dataset. The model learns to recognize patterns in the data that distinguish spam from legitimate emails. Finally, you evaluate the performance of the model using metrics like accuracy, precision, and recall to ensure it is effective in filtering out spam emails. What is reinforcement learning, and how does it work in a game environment? Answer: reinforcement learning is a type of machine learning where an agent learns to make decisions by receiving rewards or penalties for its actions. In a game environment, the agent receives a reward when it reaches the goal and a penalty when it hits obstacles. The goal is to optimize the agent's actions to achieve the best outcome. For example, imagine a game where the agent is a character that needs to reach the exit. The agent starts by moving randomly, but as it receives rewards for reaching the exit and penalties for hitting obstacles, it learns to optimize its movements to reach the exit quickly and efficiently. Over time, the agent becomes better at navigating the game environment and making decisions that lead to the best outcomes. How does transfer learning work in neural networks? Answer: transfer learning is a technique in neural networks where a pre-trained model is taken and fine-tuned on a new, related task. This allows the model to learn quickly with less data by leveraging the knowledge it gained from previous tasks. The pre-trained model has already learned general features and patterns from a large dataset, so when it's fine-tuned on a new task, it can adapt quickly to the new task by making small adjustments to its existing knowledge. This results in better performance and faster learning on the new task, especially when there is limited data available. What is semi-supervised learning? Answer: semi-supervised learning is a machine learning approach that uses a combination of small amount of labeled data and a large amount of unlabeled data to train a model. The model initially learns from the labeled data and then refines its learning using the unlabeled data. This approach is cost-effective when labeled data is scarce, as it makes use of both labeled and unlabeled data to improve the model's performance. Explain the SVM algorithm in detail. Answer: the support vector machine SVM algorithm is a powerful classification technique that finds the optimal hyperplane to separate data points of different classes. It works by maximizing the margin between the nearest points of each class, known as support vectors. The algorithm starts by mapping the data points into a high-dimensional space using a kernel function, which allows it to find a linear separation between the classes even if they are not linearly separable in the original space. The SVM then finds the hyperplane that maximizes the margin between the classes, which is the distance between the nearest points of each class. This hyperplane is the decision boundary that separates the classes. The SVM algorithm is known for its ability to handle high-dimensional data and to provide good generalization performance, making it a popular choice for many classification tasks. What is the main difference between lasso and ridge regression in terms of the regularization effects on model coefficients? Answer: the main difference between lasso and ridge regression is that lasso-alone regression shrinks some coefficients to zero, leading to feature selection and a simpler model, whereas ridge-L2 regression shrinks coefficients but never to zero, making it better for models with many correlated features. This means that lasso regression can eliminate irrelevant features, while ridge regression reduces the magnitude of all coefficients, but does not eliminate any. How does a neural network work? A neural network is a complex system that consists of multiple layers of nodes, also called neurons. These nodes process the input data and pass it through activation functions, which help to introduce nonlinearity into the data. The nodes are connected by edges, and each edge has a weight associated with it. The network learns by adjusting these weights during a process called backpropagation. Backpropagation is an optimization algorithm that minimizes the error between the network's output and the desired output. This process is repeated multiple times, and the network becomes more accurate with each iteration. Neural networks are widely used for tasks such as image and speech recognition, natural language processing, and more. What is a convolutional neural network, CNN? A convolutional neural network, CNN, is a type of neural network specifically designed for image processing. It uses convolutional layers to scan images, identifying patterns such as edges or textures. These layers help extract features efficiently, making CNN suitable for tasks like object detection and image classification. In other words, CNN are designed to recognize and analyze visual patterns in images, which is crucial for many applications in computer vision and machine learning. What is a recurrent neural network, RNN? A recurrent neural network, RNN, is a type of neural network designed to handle sequential data, such as time series or text. Unlike traditional neural networks, RNN have loops that allow information to be stored and passed from one time step to the next, enabling them to learn and make predictions about patterns in sequential data. This makes RNN particularly useful for tasks like language modeling, time series prediction, and speech recognition. In essence, RNN are ideal for processing data that has a temporal or sequential structure. What is the concept of long short-term memory, LSTM, and how does it solve the problem of long-term dependencies in RNN? Long short-term memory, LSTM, is a type of recurrent neural network, RNN, that overcomes the problem of long-term dependencies by using gates to control the flow of information. This allows LSTMs to remember or forget specific information over long sequences. The gates, including the input gate, output gate, and forget gate, regulate the addition, removal, and modification of information in the cell state, enabling LSTMs to learn and remember patterns in data over extended periods. This makes LSTMs particularly useful in natural language processing, NLP, and time series analysis applications. What is reinforcement learning, and how is it different from other types of learning? Reinforcement learning is a type of machine learning where an agent learns to make decisions by interacting with an environment and receiving rewards or penalties for its actions. This is different from supervised learning, where an agent is trained on labeled data, and unsupervised learning, where an agent discovers patterns in data without labels. In reinforcement learning, the goal is to learn a sequence of actions that maximizes the cumulative reward, which is not the case in supervised and unsupervised learning. This unique approach allows reinforcement learning to be applied to complex problems such as game playing, robotics, and autonomous driving. What is the Bellman equation in reinforcement learning? The Bellman equation is a mathematical formula that describes the relationship between the value of a state and the values of its successive states. In reinforcement learning, it helps to determine the optimal policy for maximizing rewards by finding the maximum expected value of taking an action in a given state and transitioning to a new state. The equation is a key concept in dynamic programming and reinforcement learning, allowing agents to learn from their environment and make decisions that maximize rewards over time. What is Q-learning and how is it applied? Q-learning is a type of reinforcement learning algorithm that helps an agent learn the best action to take in a given situation. It does this by creating a Q table, which is a table that stores the expected reward for each action taken in each state. The agent then uses this Q table to decide which action to take in each situation. Q-learning is applied in various scenarios, such as robotics, game AI, and self-driving cars, where the agent needs to learn how to take optimal actions to achieve a goal. For example, in a self-driving car, Q-learning can be used to learn the best route to take to reach a destination while avoiding obstacles. The algorithm updates the Q table based on the rewards received for each action, allowing the agent to learn and improve over time. This makes Q-learning a powerful tool for solving complex problems in a wide range of fields. What is Bayesian optimization and how does it help in optimizing expenses to evaluate functions? Answer Bayesian optimization is a technique used for optimizing functions that are expensive to evaluate, such as hyperparameter tuning in machine learning models. It works by building a probabilistic model that predicts the performance of different configurations, allowing it to find the optimal solution faster. This is achieved by iteratively sampling the function, updating the model, and using it to guide the search for the optimal solution. As a result, Bayesian optimization can significantly reduce the number of function evaluations required to find the optimal solution, making it a powerful tool for optimizing complex functions. How do you prevent model drift in a machine learning model? Answer: to prevent model drift, you can monitor the model's performance over time, retrain the model periodically with updated data, and use drift detection algorithms to trigger retraining when drift is detected. This helps to ensure that the model remains accurate and effective even as the data it sees changes over time. By regularly updating the model and detecting changes in the data, you can prevent performance degradation and maintain the model's reliability. What are the key differences between batch learning and online learning and machine learning? Answer: batch learning involves training a model on the entire dataset at once, which is suitable for static data. On the other hand, online learning involves updating the model continuously as new data arrives, making it suitable for dynamic environments. The key differences between the two are that batch learning is a one-time process, whereas online learning is an ongoing process. Additionally, batch learning requires the entire dataset to be available, whereas online learning can process data as it arrives. This makes online learning more suitable for applications where data is constantly being generated, such as real-time analytics or recommendation systems. What is model interpretability, and why is it important in machine learning? Answer: model interpretability refers to the ability of a machine learning model to provide clear and understandable explanations for its predictions or decisions. This is important because it allows users to trust and understand the model's outputs, which is crucial in applications where accuracy and transparency are vital, such as healthcare, finance, and law enforcement. Without interpretability, models may be perceived as black boxes that make decisions without justifiable reasons, leading to a lack of trust and accountability. By providing insights into the model's decision-making process, model interpretability enables users to identify biases, improve the model's performance, and make informed decisions. What is the main difference between inductive and deductive machine learning approaches? Answer: inductive machine learning involves creating generalized rules from specific examples, such as learning patterns from data. On the other hand, deductive machine learning starts with known rules and applies them to specific cases, such as making a prediction by applying a learned rule. In other words, inductive learning is about discovering patterns and rules from data, while deductive learning is about applying known rules to new unseen data. This fundamental difference in approach has significant implications for how machine learning models are trained, validated, and used in real-world applications. What is backpropagation, and how does it work in neural networks? Answer: backpropagation is a method used to train neural networks by calculating the gradient of the loss function with respect to each weight. It works by propagating the error backward through the network, from the output layer to the input layer. This allows the network to adjust its weights to minimize the error and improve its performance. In other words, backpropagation helps the network learn from its mistakes by adjusting the weights to reduce the difference between its predictions and the actual output. This process is repeated multiple times to refine the network's performance. What is a generative adversarial network GAN? Answer: a generative adversarial network GAN is a type of artificial intelligence model that consists of two neural networks, a generator and a discriminator. The generator creates fake data, while the discriminator tries to distinguish between real and fake data. This competition between the two networks improves both models, resulting in realistic outputs. The generator learns to create data that is indistinguishable from real data, while the discriminator becomes better at identifying fake data. This process continues until the generator produces data that is indistinguishable from real data, and the discriminator is unable to distinguish between real and fake data. This is a powerful tool for generating realistic data such as images, videos, and music. What is an autoencoder, and how does it work? Answer: an autoencoder is a type of neural network that is used for dimensionality reduction. It works by taking in a high-dimensional input, compressing it into a low-dimensional representation, and then reconstructing it back to its original form. This process is done by minimizing the loss between the original input and the reconstructed output. Autoencoders are widely used for tasks such as anomaly detection and image compression, as they can learn to identify patterns in the data and reduce the dimensionality of the input. In essence, autoencoders are like a digital mirror that reflects the input data back to itself, but with a lower number of dimensions. This allows for efficient representation and processing of high-dimensional data. What are activation functions, and why are they important in a neural network? Answer: activation functions are special functions that determine the output of a neuron in a neural network. They are important because they introduce nonlinearity to the network, allowing it to learn and recognize complex patterns. Without activation functions, the network would only be able to learn simple relationships between inputs and outputs, limiting its ability to make accurate predictions or classify data effectively. Examples of activation functions include the sigmoid, ReLU, and tan functions, each with its own unique characteristics and uses. What is the main difference between the sigmoid and softmax activation functions in a neural network? Answer: the main difference between the sigmoid and softmax activation functions is their output range and purpose. The sigmoid function produces an output between 0 and 1, making it suitable for binary classification problems where the output is a single probability value. On the other hand, the softmax function outputs a probability distribution across multiple classes, making it suitable for multi-class classification problems where the output is a set of probabilities for each class. In other words, sigmoid is used for yes/no or true/false predictions, while softmax is used for predicting the probability of each class in a multi-class classification problem. What is the ROC curve, and how is it used to evaluate a classification model's performance? Answer: the ROC receiver operating characteristic curve is a graphical representation that plots the true positive rate against the false positive rate of a classification model. It helps evaluate the model's performance by showing the trade-off between true positives and false positives at different threshold settings. The area under the curve AUC provides an overall measure of the model's accuracy, with higher AUC values indicating better performance. The ROC curve is widely used in machine learning and data science to compare and evaluate the performance of different classification models. What is the Gini index in decision trees, and how does it help in choosing the best feature to split on? Answer: the Gini index is a measure of impurity in a node of a decision tree. It calculates the probability of misclassifying a sample from the node by randomly guessing the class label. A lower Gini index indicates a better split of the data, as the classes are more homogeneous. The algorithm uses the Gini index to choose the best feature to split on, as it helps to reduce the impurity and increase the purity of the classes. This results in a more accurate and efficient decision tree. In other words, the Gini index is a tool that helps the algorithm to make the best decision about which feature to use to split the data in order to create a more homogeneous and accurate classification. How do you prevent overfitting in deep learning models? Answer: to prevent overfitting in deep learning models, you can use several techniques. One common method is to use dropout, which randomly drops neurons during training. This helps prevent the model from relying too heavily on a specific set of neurons and reduces overfitting. Another technique is to apply regularization, such as Lone or L2 regularization, which adds a penalty term to the loss function to discourage large weights. Additionally, you can add more data to the model or use data augmentation to increase the diversity of the training data, making it harder for the model to overfit. By using these techniques, you can reduce the risk of overfitting and improve the generalization performance of your deep learning model. What is dropout in neural networks? Answer: dropout is a regularization technique used in neural networks during training. It randomly deactivates some neurons to prevent the model from relying too heavily on specific neurons, which helps improve the model's ability to generalize to new, unseen data. This technique is useful in preventing overfitting, where the model becomes too specialized to the training data and fails to perform well on new data. By randomly dropping out neurons, the model is forced to learn to rely on other neurons, making it more robust and less prone to overfitting.